Hello friends, welcome to Tulsi classes making science a passion. Today we will do the formulas. I am writing the formula and explaining you what are the significance of the symbols that I have used regarding current and electricity. If time permits and video will not become long, then I will also cover magnetic effects of electric current. First of all, let us start with formula number 1, capacity represented by C of a conductor. Now what is capacity? Capacity means a conductor has a capacity to store charge in itself. The charge is stored in itself. That is called capacity of each and every conductor. So capacity is defined as Q by V. That means charge required to increase the potential difference by 1 volt. SI unit is farad for capacitance. Okay. And symbol of capacitor is this one. Now, why I have drawn two symbols? The reason being, if the capacitor has a fixed capacity, this is for fixed capacity. If in the exam symbol is asked or the difference, then this is for fixed capacity and this is for or fixed capacitance and this is for variable capacitance. That's why arrow is there. Variable capacitance. Two symbols are there. SI unit is farad, and farad is a very big unit. Why? I will tell you in the third point why farad is big unit, and we generally use picofarad, small pf, picofarad or nanofarad in our use in the calculations that numerical is given. Why? I will tell you. So capacity C of a conductor is equal to charge required in the conductor to increase its potential by 1 volt, that is Q by V, SI unit farad. Now if parallel plate capacitor is there, then its formula to find its capacity is equal to epsilon naught A by D. Epsilon naught A by D. Now how the parallel capacitor looks like? Okay, I am erasing this part. Okay, I am erasing capacity C is equal to Q by V, and SI unit always remember it is farad. Let me remove this. Parallel plate capacitor. Parallel plate capacitor is like this. Two plates are there. Okay, two plates are there on one plate. Suppose this is plate A, this is plate B. On plate A, if we have provided charge, these are positive charge on both sides, and a plate B, if we will bring near it, then the charge on A will get induced in B and the front side of B will become negatively charged and the rear side of B will become positively charged. In this way, this is the sequence, and then we will underground this B. This B conductor, that is a parallel plate, will be underground, then capacity of A will increase further. Now, don't get into the long concept, just you have to remember epsilon naught A by D. What is A? A is the area of the parallel plate, area of each plate. They both are equal in area. Area of plate is equal to A. And D, what is D? D is the separation between the two plates. Separation between the plates. So if separation between the plates and area of plate is given, don't write the area twice, only one times you have to write this, you will remember, don't multiply 2 with it. Epsilon naught A by D, SI unit meter square, and here it is meter. Epsilon naught is the medium. See here I am shading, if you can see this shaded portion, this contains a medium. If medium is air or vacuum, that is, this medium is called dielectric. This is dielectric. Now, in this medium, this dielectric can, here vacuum is as dielectric, that's why I have written dielectric, and this epsilon naught will change to only epsilon, and the value of epsilon will be given to you. This will become, formula will become, let me erase this. Otherwise, the formula will change, and now it is epsilon naught A by D. Epsilon naught, you know the value, 8.85 into 10 raised to the power minus 12. So you will put the value epsilon naught A by D and get the capacity of parallel plate capacitor. Okay, let's move to the next formula. Now the next formula is capacity of a spherical conductor. This conductor may be, spherical conductor may be a solid sphere or a hollow sphere. Formula remains same. C is equal to 4 pi epsilon naught R. 4 pi epsilon naught R, and you will get the capacity of the spherical conductor. For your reference, I am telling you capacity of earth, if you will calculate, no, or capacity of a conductor which is of the size of earth, spherical conductor. So capacity of earth, in this way you can tell it is 711 microfarad. How I have got this? If instead of R you will put the radius of the earth and 4 pi epsilon naught value you know, so you will get 711 microfarad. So see, it is also coming in microfarad, even though earth is a very large conductor, means the size of the conductor which is of the size of the earth is very high, or the capacity of earth. That's why in general we use picofarad. I told you picofarad, and 1 picofarad is equal to, I am writing here, 1 picofarad is equal to 10 raised to the power minus 12 farad. This is the conversion. You have to remember, if the option is given in picofarad, then you will choose option accordingly. One more thing, if 1 nanofarad is given, 1 nanofarad, then I am erasing this, as you have seen this thing, 4 pi epsilon naught into R. R is the radius of spherical conductor. R is radius. R is what? It is radius of conductor. See, here I have written radius of conductor, that you will put in SI unit meter. Let me erase this part. And one thing I am telling you, 1 nanofarad, small n, capital F, is equal to 10 raised to the power minus 9 farad. 1 picofarad I have already told you, 10 raised to the power minus 12 farad. Okay, and 1 microfarad is equal to 10 raised to the power minus 6 farad. These are the conversions. Coming over to grouping of capacitor, like we know in I think class 9 also some questions were there in some of the books, that we there what we did, we grouped the resistors either in parallel or in series. Parallel means like this, resistors were grouped, one resistor, second resistor, like this in series, and this was in parallel. If we will connect, suppose like this, if two resistors are connected such that first end of both the resistors are connected once and the second end, that means positive and negative terminals are connected to each other like this, battery is there, that is parallel, and this is series. This is what? Parallel connection. Parallel connection. Positive ends are connected at one place, negative ends at one place. And if positive end of one, suppose this is cell here, if cells are connected like this, then positive end of one cell is connected to negative end of another cell in this way. So this is series. Marker gone, I think. Okay. This is series, and this is also series. Series connection, this is called. Okay friends, series connection. In this way, as this is the symbol for resistor, you will find the symbol for capacitor. In this way, this is parallel combination of capacitor, it will become, and in the same way, if we will remove the symbol, it will become, sorry, this will become parallel connection, and this is series connection by mistake. Okay, I told that. Series and parallel I have written. Now, how to find equivalent resistance? Suppose n number of capacitors are grouped in series connection. N number of capacitors are grouped in series connection. Then 1 by Cs, Cs is the equivalent capacitance, will be equal to 1 by C1, you will put the value, plus 1 divided by the value of C2, plus 1 divided by the value of C3, plus in the same way, and then you will reverse it to get Cs. This is 1 by Cs. So this is the equivalent capacitance when capacitors are grouped in series. Remember this. Now how to find equivalent capacitance only if capacitors are grouped in parallel, in this way, parallel, then how to find? So I am erasing this. This is what, friend, this is series connection of batteries. This is regarding battery, these are resistors, parallel connection, these are resistors. I think you can read this, resistors. Now we are talking about capacitor. So in parallel connection, capacitors are connected parallelly. There what you will get, Cp, that means P I am writing for parallel, equivalent will be equal to C1. Simply you have to add C2 plus C3 plus up to how many are there. Suppose n capacitors are there, so up to Cn we will directly add as we do the sum. Here we will not do 1 by Cs and 1 by C1. Remember this. You can take a screenshot. In the series also I have taken, you can pause the video and take the screenshot. Now this is for parallel. These are very important things. Let's move to the next concept. Take the screenshot. Okay. Now the formula says energy stored in capacitor, that means the potential energy that is there in capacitor. Here capacitors can also be there. Then what you will do, energy stored in each capacitor will be added separately. Its formula says U is equal to half QV. Now, just now, I think 5 minutes before I told you a formula, capacity is known as Q by V, charge required to increase the potential by 1 volt. From here you can get Q is equal to CV. Now you have got Q is equal to CV. If we will replace Q here, this will become half into CV. Q is CV multiplied by V, CV square. These are nothing but this is the general formula. We are only writing by transposing this formula. Q is equal to CV. Now from here you can also get V is equal to Q by C. I think it will not be visible, so I am writing here V is equal to Q by C. Putting it in this formula, 1 by 2, this is Q by C, so this will become Q square by C. These are the three formulas, anyone you can use according to the data given to find the energy stored in capacitor. And one more thing I am writing, to find energy stored in a group of capacitors, I think it is visible, we add the energies of each capacitor. Each capacitor U1 plus U2 we will add plus U3 plus U4 like this. Next formula we are going to move. The next three formulas are related to current, electricity. See, I am writing 1, 2 because I am forgetting which number formula was there before erasing the thing. So I is equal to Q by T. I says current in ampere. SI unit is ampere. I is current. Its SI unit of I is ampere, denoted by capital A. Current is equal to charge per unit time. If any conductor is there, this is a conductor, this is a wire, suppose of this thickness. Actually in real life this thickness wires generally we don't use at home. So this thickness of wire is there, its cross sectional area is there, this is its cross sectional area. So okay, that is not here. Okay, Q by T. So charge passing through any cross sectional area per unit time. If charge is flowing here, see here, charge is flowing, so through any one cross sectional area, let it be this, let it be this, or let it be this, through this area how much charge is flowing, how many coulombs of charge is flowing per second. Okay, charge flowing per second. In 1 second how many coulombs passes through this cross sectional area, that is defined as current. I is equal to Q by T. Q is charge and T is time. Next formula says V is equal to IR. V is potential difference. V is not potential, it is potential. Potential difference. This was derived from Ohm's law. Ohm's law, there is a graph which says V is equal to IR. How he got? Because we know from this formula I is equal to V by R. Potential, this R resistance is a constant. V is directly proportional to I. V is directly proportional to I, remember this. If we will increase the potential difference, the amount of current will also increase. If potential difference is increased, see, this is important, okay? If potential difference increases, then current through conductor, also increases. That's why I have written V is directly proportional to I. And from here you get I is equal to V by R, V is equal to IR. Anything you can say. I is current, V is potential difference, R is resistance. Its SI unit is ohm. Read this, I will erase this. Okay. R is resistance of conductor. R is resistance offered by conductor. SI unit of R is ohm, OHM, okay? And how it is represented? It is represented by omega. Omega, this is the symbol, Greek letter omega, and SI unit, its name is OHM, ohm. R is the resistance, I is current in ampere, V is potential difference in volt. So this is the thing about this formula number 2. Oh, okay, one more thing is there. R resistance is equal to rho L by A. So this says, so here, ohm is the SI unit, I have written. Now, resistance of a conductor is directly proportional to its length. If the conductor is a long wire, then resistance offered by it will increase. Resistance is inversely proportional to area. If area of the conductor increases, resistance offered will decrease. And combining these two, we get R is equal to rho L by A. Rho is a constant, as you can see, we have combined these two. So rho is called, what it is called? Resistivity, not resistance, resistivity of conductor. And this resistivity, remember, resistivity of conductors are different. It depends upon the material by which conductor is made. Like gold has very less resistivity. Gold, I think least resistivity, gold and silver. So rho is called resistivity of the conductor. From here, R, I have told you its formula, its SI unit is ohm. You can get the resistivity unit, SI unit. So what you will get? Rho, I think rho will become, let us write, SI unit of rho. How much it will become? Ohm meter. This it will become. Ohm meter is the SI unit of resistivity. Okay. Now G, what is G? G, I have written 1 by R. G is 1 by R, as you can see. That means reverse of resistance. And in English language also we say resistance. So, you know, conductance. This way you can remember. This is a way to remember. G is equal to conductance of the conductor. So it is reverse of resistance as it is conductance. G is conductance. What is G? Conductance. G is conductance, reverse of resistance. SI unit. See, SI unit, actually the unit that is SI unit is used is Siemens. But initially this was, its unit was mho, MHO. OHM is ohm, okay, that is resistance. So its opposite is conductance. That's why people said it is correct. You can see, search, people said is MHO. But now Siemens is used. Moving over to the next formulas. Okay friends, so the next formula is P is equal to V square by R. P is power. P is power. Let me write. P is power consumed. V square, you know, potential difference V square by R. And as we know, I am writing here, as we know, V is equal to IR. Putting this in this formula, what we will get? This will become how much? I square R. This will also become equal to I square R, as you can see. Or this can also become, if we will replace I, okay, then it will become how much? V square by R, I square R, or this will become how much? VI. See, VI we have written, VI. Why? Because R is equal to V by I, V square divided by V by I. And from here you can get R is equal to V by I. That's why we have written V square by V by I. So it will become V square into I divided by. So this is confusing, I think, for you. I am writing it here. From here we will get power is equal to V square into I by V. So this will get cancelled, VI. That's why I have written VI. Three formulas, all three you have to remember. For power, SI unit of power is what? Watt. SI unit of power is watt, represented by capital W. Okay. Now electrical energy I have written, no formula. Now I will write you and tell you electrical energy. Energy is what? You have learnt energy is equal to work done multiplied by time. Work done multiplied by time. So this is the work. Okay, wait. Power is equal to work done by time. So work done is equal to power multiplied by time. So power, if this we will multiply the formula above with time, we will get the total work done or the total electrical energy or the total heat energy, anything. Please remember, this is the thing, heat energy. The person or the examiner may also ask what is the heat energy consumed, and data will be given. So this will become electrical energy. This is power multiplied by time, which is equal to, you can write VIT, or that is equal to I square RT, or that is equal to V square by R into T. All these are formulas. We have multiplied simply time by power. And SI unit of electrical energy is joule. SI unit. SI unit of electrical energy is joule, and joule you know, capital J. Electrical energy is nothing but one kind of energy only. So this is the thing. What type of question you may get here, I am telling you what type of question. Suppose the current that is used by an iron, okay, current used by an iron, the iron that we use to press cloth, current used by an iron is, it will be given, suppose how much, 3 ampere, and potential difference is, it will be given that we use in home, that is 220 volt. 220 volt is the potential difference, 3 ampere the iron is using current. If a person irons for 15 minutes find heat energy consumed or like that. So how will you solve? Now you see here potential difference and I is given, I and V is given, I V into T, I V into T, and T will not be 15 minutes, it will be converted to second, and then we will get the answer in joule. Let me erase this one. This type of question may come, that's why I have told you. So this will become V into I, heat energy E, that is electrical energy I am telling you again, is equal to V I T. From here, I is this much, V is this much. 220 into 3 into 15 minutes. This is 15 minutes. So 15 multiplied by 60 in second. Do the calculation. How much it will become? 15 3s are 45 into 6. How much it is? 6 5s are 30. 0 3. 270 it is becoming. Okay. So 270 10 and this here into 220. You will multiply this. Wait, I am multiplying. It will become 27 multiplied by 22. 27 multiplied by 22. 594 I am getting. So this is equal to 594,000. This much joule, or 594 kilojoule. 594, this is 9. 594 small k capital J, 594 kilojoule. In this way a question may be given from this formula. Let's move to the next concept. Now friends, see, this is the last formula for today's video because video is becoming longer. The last formula says units of electricity consumed. You know, in our home the electricity bill is there, 500 units, 800 units, and accordingly we pay the bill. Suppose 5 rupees per unit is the amount that we have to pay, then we will multiply the units that we have consumed with 5 rupees, like that. So how to calculate units of electricity consumed? The answer is V into I into T. I have written hour. Be careful. V I T in hour divided by 1000. This will give you how many units of electricity has been consumed. If you want to directly remember the formula, you can directly remember. Some students are there who want to know how this formula came. For them I am telling something. Here. See, VIT. What is VIT? Electrical energy. Electrical energy is equal to VIT. But here T was in second, as you remember. T was in second. Here why we have taken in hour? Because what happens, what is the standard set in our country? That 1 kilowatt hour is equal to 1 unit of electricity. 1 unit of electricity you have spent means you have used energy equivalent to 1 kilowatt hour. See here, kilowatt is there, that's why we are dividing by 1000. Hour is there, that's why we have used hour in the formula. Time must be converted to hour and 1000 must be divided. 1 kilowatt, so kilowatt and hour. That's why we have done this thing. Okay, 1 kilowatt hour. That means if a substance is there, suppose heater, in college we must be using, what thing we use? Electric kettle to make Maggie and all that. So electric kettle, suppose its power rating is 1 kilowatt, 1000 watt. Yes, it is there. Actually it is 1500, I think, 1000 watt. If for 1 hour we will use it, we will use an electric kettle for 1 hour whose rating is 1000 watt, then 1 unit of electricity will be consumed and you have to pay accordingly, like rupees 5, I think, as it is there generally in many areas. So 5 rupees you have to pay for running 1 hour the electric kettle whose rating is 1000 watt, 1 kilowatt. Now 1 kilowatt hour is equal to how many joule? So 1 kilowatt means 1000 watt, 1 kilowatt multiplied by hour, 3600 second. How much you are getting? 3.6 multiplied by 10 raised to the power 6 joule. See, 1, 2, 3, 4, 5 and 6, 3.6. This is very important. If you have skipped the video, then what I can say, I am telling you, don't skip the video. this is very important formula, 1 kilowatt hour is equal to how many joule. In the same way you may be given, suppose convert 5 kilowatt hour into joule. I am giving you one question also, because this is the last part of the video. I am giving you a question. If a man consumes 5 units of electricity in his home, then how many joules of electric energy has he used? If you will get this formula, then what you will do? 5 units of electricity. 1 unit is equal to 1 kilowatt hour. We know 1 unit is equal to 1 kilowatt hour. 5 units is equal to 5 kilowatt hour, and 1 kilowatt hour. So how much it will become? 5 kilowatt hour is equal to, with this we will multiply 5, 3.6, with blue ink I am writing, 3.6 multiplied by 10 raised to the power 6 multiplied by 5 joule. Calculate it, 36 5s are 18. Okay, 18 into 10 raised to the power 6 joule. This is your answer that you will get. So that's all about today's video, as you can see here. Okay, that's all about today's video, friends. And I want to request you one thing, that only a few percent of the students, or only a few percent of you who are watching the channel are subscribing. Please subscribe the channel if you watch the channel, and press the bell icon to get the latest update. Okay, and the thing that is left is carbon code for code for carbon resistor, how to find. If a code will be given, what is its resistance, and in the same way Kirchhoff's law is remaining before moving to magnetic effect of current. These two are somewhat bigger, you can say, in length. We have to cover 2 concepts, will only be covered: Kirchhoff's law in a video, and in the same video I will cover code for carbon resistor, what is its meaning, accordingly with one question on both Kirchhoff's law and coding. So these two we will cover, and if time permits I will upload magnetic effects of electric current formula. Otherwise you also try to learn from the books. Okay, thank you.